Welcome to Study Loop.
Okay, so here we're mimicking iron balls that are solid all the way through with hollow gold balls. In order to smuggle them through security. And what we want to do is we need to find how thick these walls need to be. In order to mimic it as fake iron ore. So what we want to do is we want to first find the volume and the mass that a real iron ore ball would exhibit, and then we can apply this to the mimic. So we know the diameter is going to be 6 centimeters, which means our radius is 3 centimeters. And to find the volume of a sphere, the formula is V equals 4/3 pi r cubed. So here if we substitute in our radius, we get a volume of 113.1 cubic centimeters. So this is going to be the volume. This is going to be the volume that's filled in the sphere. And so if we used iron ore, we want the two balls to have the same density. If we used iron ore, we can find out the mass that this ball should weigh. So using the density of iron, we know that 1 cubic centimeter is 5.15 grams. So 113.1 times 5.15 is 582.5. So this is the mass that the mimic ball should weigh in order to have the same density. So now we need to find out how much gold this is. We can find out the volume of gold that's needed to be used and use this to calculate what the thickness will end up being. So if we take 582.5 grams of gold, this is how much gold that we're allowed to use. Sorry, this should be AU. In order for the balls to have the same density, and we can use the density of gold to convert this into a volume. So 19.3 grams of gold are in 1 cubic centimeter. So 582.5 divided by 19.3. And we get a volume of 30.18 cubic centimeters. So what we know is that the volume of a sphere should be equal to the volume of gold plus the volume of the hole. And we know the volume of the sphere, we now know the volume of the gold, and we can solve for the volume of the hole. So the volume of the sphere is 113.1. Our volume of gold that we are allowed to use is 130.18, and we don't know the volume of the hole. So this comes out to a volume of 82.92 cubic centimeters. So the reason why we want to calculate the volume of the hole is that we want to find out the thickness of the gold layer. And how we can do this is we know the radius of the sphere, and we can calculate the radius of the hole because now we have its volume. So we can calculate this radius here. And if we look, put that in purple. If we look, the difference between the radius of the sphere and the radius of the hole is actually the thickness of the gold layer. So first, if we solve for the thickness of the hole and then use subtraction to find the we can then use subtraction to find the thickness of the gold layer. So the volume of the hole is 82.92 cubic centimeters. And we can actually put this back into the volume equation and solve for radius. So 82.92 times 3 divided by 4 and divided by pi gives us 19.80 equals r cubed. And you can take the cubed root of both of these. So r comes out to 2.71 centimeters. So then to find the radius of the sphere is going to be equal to the radius of the hole plus radius of the gold layer. So 3 centimeters is equal to 2.71 plus the r of gold. And r of gold is going to be its thickness. So 3 minus 2.71 comes out to 0.29 centimeters. And here we want to round it to 2 sig figs, which we've done. So that's how you solve for the thickness of the gold layer.